Directions: simplify each radical, express all the odd problems with the rational numerators or with rational numerators, and the even problems with rational denominators. All right. So what that's saying is for all the odd numbered problems, I need to get the radicals out of the numerator. All right. It really doesn't matter what's happening in the denominator as long as the radical's gone from the numerator. All right. So what I look to do anytime I see a fraction is I look to simplify it as much as I can before I do anything fancy. All right. First thing I notice here is something hopefully before too long you'll find to be obvious: the presence of a perfect square. All right. If you're not comfortable with perfect square values, make a list on the top of every paper that you're working on, whether it's a test or a quiz or an activity. You just go to your graphing calculator, type in y equals x squared, go to the table, and then just write down the first few values, or just refer to your calculator. But it's nicer to have it right on paper, right in front of you, so that you can just look up. You don't always have to go to your calculator. So 1, 4, 9, 16, 25, 36, 49. I got a little fancy last time, and I went out to, I think, 15. Really, 10 is a pretty good number to go out to. So 64, 81, and 100. All right, if you have those numbers at the ready, and it's a quick sight analysis where you just look at it and say, oh, that's a perfect square. All right. You would also need to know what the square root of that number is, but recognizing it as a perfect square is helpful, because then you could say, even if you don't know what the square root is, you could say, okay, well, I'll just go to my calculator and figure it out there. So let's say I don't know what the square root of 16 is, but I do know it's a perfect square. Then at least for the time being, until I have it memorized, which you will eventually if you don't already, you'll eventually pick up that it's 4. All right? So I'm looking at 5 radical 7 over 4. Now this is a simple fraction with a rational denominator. I needed to have a rational numerator. That's what the directions are telling me to do. All right? So the way that we figure out, or the way we determine an equivalent value, but with a rational numerator, is to use the process of rationalizing. Right? And the way we do that is by multiplying top and bottom of the fraction by the radical that we don't want. Right? I don't want that radical 7 in the numerator anymore. So I'm going to multiply top and bottom by that radical 7. Then I carry out the multiplication. Now that 5 doesn't have a counterpart. I mean, it does. It's just a trivial case. We have that number 1. All right, 5 times 1 is 5. Understood coefficient. So 5 times 1 is 5. Radical 7 times radical 7 is radical 49, which we know is just 7. Or maybe you don't, in which case you would put it in your calculator and see that that's just 7. All right? And even if you don't put it in your calculator, you can still figure it out, because anytime you multiply a radical by itself, the answer is the radicand, the thing under the radical. All right? So on the bottom, these are two unlike numbers. One is rational and the other is irrational. Can't multiply them together. The best I can do is just write them next to each other. All right, so 4 radical 7. All right, then I just carry out the multiplication on the top, because 5 and 7 are both rational numbers. They can be multiplied. So 5 times 7, 35. On the bottom, 4 radical 7. So that would be my answer. It doesn't look very simple, but I can't simplify the rational numbers any further. If you're ever unsure about that, you ignore the radicals. I got a 35 and a 4. Go into your calculator, alpha y equals, get that fraction tool, type in the 35, type in the 4. Like I said, ignore the radical. It didn't simplify it, so it can't be simplified. All right? We've already worked the radical as much as we can. Radical 7 is well, 7 is a prime number. It can't go any further, right? It's not there. You're not going to find two numbers that'll multiply to 7 where one of them is a perfect square that can be simplified, right? So this is as far as you can go. Now, number 2 is saying to do pretty much the same thing, but with a rational denominator. All right, same idea, but with a rational denominator. So I look for the obvious part, and it doesn't always play out that way. Sometimes you see in like number 4, you know, you get a radical 8. You'll have to simplify that. You know what? I'll do number 4 for you also. But let's do this one real quick first. So radical 16 is the same as 4. You know, I say radical 16. That's the same as saying the square root of 16. Why do I say radical? Less syllables. It's easier to say. All right, the square root of. Radical. Right? Just rolls off the tongue. So I say it that way, but it really means the square root of. So when I say radical 16, I'm asking you, what is the square root of 16? You say 4. So we could write this as 5 times 4. We have the radical 7 on the bottom. That 5 times 4 is the same as 20. So I have 20 over the square root of 7. But the directions here say that I need to have rational denominators. So the bottom of my fraction needs to be rational. So this is a simple form. This is fine under normal circumstances. But we're being told that I need to have a rational denominator. So what do? I multiply the top and bottom by the radical I want to get rid of. I want to get rid of that radical 7 in the bottom of the fraction. All right, so then I would say, okay, well, what's radical 7 times radical 7? Anytime you multiply a radical by itself, the answer is just the radicand, the thing under the radical. The numerator is comprised of rational number and irrational number. Can't multiply them together except to just write them adjacent to one another. So 20 radical 7 over 7. And like I said, I would do number 4 for you, just because it's an extra little ingredient there. The thing about number 4 is that you have a radical 8 as part of the denominator. I need to have a rational denominator. So we could go through the process of rationalizing, you know, multiplying top and bottom by the radical you want to get rid of. But that radical 8 could be simplified. So it's a question of, do you want to simplify now or do you want to simplify later? Most people, I'll be honest, most people forget to simplify in the first step and end up having to simplify later on. So you want to get yourself, that's why I'm going over this, you want to get yourself in the habit of looking at the quality of your fraction and saying, can I simplify it immediately? Like that radical 16, I looked at it and said, that's perfect square. That could become a 4. Let's do that right away. That radical 8, it's not a perfect square, but it is a product that involves a perfect square. So we do the tree diagram. Not much of a tree, but you get the idea. All right? It's the product of radical 4 and radical 2. Remember what we talked about 2 days ago? We look at our number line. There's a lot of constantly looking back and forth between what you have in the problem and your number line, your perfect square list, your calculator, just kind of making sure you're getting all the ingredients. We always look for, as our first possibility in terms of a factor, a perfect square factor, half of whatever the radicand is. Radicand is 8. Again, radicand is number under the radical. So I look for half of that and I say, is that a perfect square? Yes, 4 is a perfect square, so that works out nicely. All right. If I had 50 comes up. I look at 50. Half of 50 is 25. Is that a perfect square? Perfect. Wonderful. All right. 96. Is half of 96 a perfect square? No. So then I would look for another number. I'd work my way down the list from there. You know, so these are things that you want to keep in mind. But the square root of 4 is 2. Radical 2 comes along for the ride because I can't take the square root of 2. It's irrational. So this replaces that radical 8. So 5 radical 3 over radical 8 is equivalent to 5 radical 3 over 2 radical 2. So now it's simpler, believe it or not. It doesn't look simpler, but it is. But I need to have a rational denominator, meaning the radical that's in the denominator has to go. How do we do that? We multiply top and bottom of the fraction by the radical we want to get rid of. All right, so on the top, the best I can do is multiply the radical 3 and the radical 2. Can't do anything with the 5 there. All right, so 5 comes along for the ride. Radical 3 times radical 2 is radical 6. On the bottom, the 2 doesn't have a counterpart, all right, except to say the understood coefficient in front of the radical 2, but that doesn't really do anything for us. So I'll just bring that along. But I can multiply the radical 2 by the radical 2. Radical 2 times radical 2 is radical 4. The square root of 4 is 2. So that's going to give me 5 radical 6 up top and 4 on the bottom. Since you can't simplify the radical 6 any further, that would be our final answer. All right, this is clearly and obviously, without me really saying anything, the most complicated problem that you're going to see. All right, so it's just right there. So this one doesn't have a perfect square in it. All right, so it's not quite as clean as number 16. The ones with radical 16 in them, but you can still simplify. Radical 8 is something that you could simplify down. All right, so what I would do is I would look at that radical 8 just kind of off on the side. All right, whenever you look to simplify a radical, I mean, unless you could do it in your head, you're probably going to be making a tree diagram. All right, so I need a perfect square value that will divide evenly into 8. So I look at my list of perfect squares, looking for any number that will divide evenly into 8. All right, I always start at half of the value of the radicand. Whatever's under the radical, chop that in half. If that happens to be a perfect square, then we have our winner. In this case, it is. So we're in good shape. Radical 4 times radical 2 will give you a radical 8. All right. The square root of 4, because again, a radical 4 means the same thing as the square root of 4. So when I say radical 4, I'm also saying find the square root of 4, which is 2. So this 2 radical 2, because the radical, this guy over here I can't do anything with, that gets popped in for the radical 8. All right. So now I have a new expression. I have 5 radical 3 over 2 radical 2 because radical 8 and 2 radical 2 are equivalent to one another. And if I type it into the calculator, radical 8, you get that decimal. 2 radical 2, you get that decimal. Timing was a little off, but you see that they're equivalent to one another, so you know that they mean the same thing. All right, now I need to have a rational numerator here because this is an odd numbered problem. All right, so I'm going to multiply top and bottom by the radical I want to get rid of. The one I want to get rid of is the radical 3, so I'll multiply top and bottom by radical 3. All right, the 5 in the numerator doesn't have a counterpart to multiply by. I mean, it does, but nothing meaningful, because there's that understood coefficient of 1. 5 times 1 is 5. But the radical 3's we can do something with. Radical 3 times radical 3 is 3. Radical 3 times radical 3 is radical 9, which is 3. All right, on the bottom, same deal. No counterpart, no non-trivial counterpart to the 2. 2 times 1, that's the best you could do. So you're really just bringing the 2 and the 5 first along for the ride. But then radical 2 times radical 3, I could actually multiply that. That'll give me a radical 6. So 15 over 2 radical 6 would be my final answer. And that's because I can't simplify or reduce my fraction anymore. and I can't reduce the radical anymore. All right. Once I carry out the multiplication, I want to be checking again to see if I can reduce, simplify further. All right. It's just like factoring completely. You factor, and then you factor again. And if you can factor more, you factor more. All right. Here you simplify. If you can simplify more, you simplify more. You keep simplifying until you can't simplify anymore. All right. So I'll leave this up on the big board, but you're responsible for the rest of the worksheet, basically. All right. So you can work together, work individually, ask for help, etc. Let's do numbers 5 and 6. Those are reasonable. Actually, we might do more than 2, but we'll see. All right. So number 5, for example, if you want to simplify, first off, the directions. Simplify each radical. Express all the odd problems with rational numerators and the even problems with rational denominators. Right? So that's really important to keep in mind. Your final answer for the odd numbered problems have to have rational numerators. No radicals in the numerators. Right? Your final answer for the even numbered problems have to have no radicals in the denominators. Right? So let's do numbers 5 and 6 together to get started, and we'll go from there. All right. We look to simplify first before you go through the rationalization process. All right. So if you see anything that's obvious, then you go through and simplify that. Because otherwise you're going to scale up the problem too much. You'll make the numbers too big, and it'll become problematic. Right. So you don't want to do that. Right. It's always a good idea to have a list of perfect square factors or just perfect squares. And just a refresher, in y equals in your calculator, you type in x squared. So this is the x key. I mean, it's other things too, but in this mode it's x squared. You go into the table, second graph, and now you have a list of perfect squares. If you just jot down a few of them, the first 10 are usually pretty good. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. All right. So if anything, so just starting with these values, if anything comes from this list, any number that you see comes from this list, it's a perfect square. All right. So here I got a 16 under a radical. That's a perfect square. That tells me that I can simplify that. All right. Now, if you don't know what the square root is, you can go into the table, you can use your calculator, but most people know the square root of 16 is equal to 4. All right. So 2 radical 5 over 4. All right. So all I did was an even swap. I replaced the radical 16 with a 4. All right. I also notice that there's a common factor top and bottom here. All right. You see that you have a 2 over 4. If this 5 wasn't there, I'm sorry, the radical 5, if that wasn't there, I'd have a fraction 2/4. I could reduce that. These are all things that you can do before you start worrying about where the radical is. All right. 2/4 reduces to 1/2. All right. So divide top and bottom by 2. You don't have to show this step. You can just go right to the next step. But the bottom line is you're going to get 1 radical 5, which is the same as radical 5, over 2. All right. The calculator will reduce fractions for you. So like I said, you have 2/4. Type in 2/4 into your calculator if you don't know that that's 1/2. Or if you're dealing with something way more complicated, alpha y equals n over d 2/4 simplifies it right down to 1/2. All right, so if you have something, like I said, way more complicated, alpha y equals 51 over 153, the calculator will take care of that for you. All right. Now, the odd numbered problems have to be expressed in a way that does not have a radical in the top of the fraction. So we need rational numerators. The way we rationalize is to multiply the top and bottom of the fraction by the radical that you want to get rid of. All right. I don't want a radical in the top of the fraction here. So that means I want to get rid of that radical 5. So I'm going to multiply top and bottom by radical 5. All right. So then when I multiply radical 5 by radical 5, that's nice and easy because any radical multiplied by itself is just what's ever under the radical. All right, the radicand. Radical 5 times radical 5 is radical 25, which is 5. Because remember, when I say radical, I'm also saying the square root of. So radical 25 is the same thing as the square root of 25. In this case, 5. On the bottom, I can't do anything with that. One number is rational and the other number is irrational. 2 times radical 5 is just 2 times radical 5. All right, and so this would be my final answer with a rational numerator. You see I don't have a radical in the numerator. But number 6, that's an even numbered problem. I need to have a rational denominator. But I would still tackle it the same way. It also happens to have a radical 16 in there, so that's kind of nice. So radical 16 is the same as 4. Again, the square root of 16. On the bottom, I have a radical 5 that I can't yet do anything with. 2 times 4 is 8. So I have 8 over the square root of 5. I need to have a rational denominator for this question. All the even problems, I have to have a rational denominator. So how do we get a rational denominator? Well, we need to get rid of that radical 5. Right? So to rationalize, you multiply top and bottom of the fraction by the radical you want to get rid of. I want to get rid of the radical 5, so I multiply top and bottom by radical 5. On the top, nothing to do there. One number's rational, the other's irrational. Can't multiply them together. The best I could do is write them next to each other. So 8 radical 5. On the bottom, that I can do something with. Same idea as the last problem. Radical 5 times radical 5, radical 25, which is 5. Again, whatever's under the radical, that's what the result is going to be when you multiply a radical by itself. All right. Let's see. Maybe I'll do one more. Really doesn't matter. I'll do number 3.